Hi students, this is Kartik Trivedi and you are watching a lecture series of Applied Thermodynamics with me. In this video, we're gonna see another topic which is effect of variable specific heat on air standard efficiency of Otto and diesel cycle. So this topic is very important from GTU examination point of view. So the theory is effect of variable specific heat on air standard efficiency of Otto and diesel cycle. So first we're going to start with the Otto cycle and then we're going to see for diesel cycle. So let us start for the Otto cycle. So now we know that for Otto cycle the air standard efficiency is equal to 1 minus 1 upon R raised to gamma minus 1, where R is compression ratio and gamma you know that it is a specific heat ratio Cp upon Cv. So can I write 1 minus 1 upon R raised to gamma minus 1 is equal to 1 minus R raised to minus R upon Cv. Why? Because in place of gamma minus 1 can I write R upon Cv? Why? Because you know that gamma is equal to what? Cp upon Cv. So gamma minus 1 is equal to what? Cp upon Cv minus 1. So is equal to Cp minus Cv upon Cv. So Cp minus Cv is equal to what? R. So R upon Cv. So in place of gamma minus 1 I can write R upon Cv. So here I am going to write R upon Cv and that will go up. So it will be 1 minus R raised to minus R upon Cv. Okay. Now can I write eta A means efficiency A is equal to 1 minus R raised to minus R raised to minus R upon Cv is equal to 1. Now eta A will be that side, so 1 minus eta A is equal to, this will come on this side, so is equal to R raised to minus capital R upon Cv. Now I'm going to take log both the sides. So now I'm going to take log ln both the sides. So this can be written as ln 1 minus eta A is equal to this R minus R upon Cv will come here. So minus R upon Cv ln R. You know that it is a property of log. Okay. So this can be like this. Now what we're going to do? We're going to differentiate. So here ln x means 1 upon x. So this will be 1 upon x. So 1 upon 1 minus eta A. 1 differentiation of 1 will be 0 and differentiation of minus eta A will be with respect to eta A. If I will do the differentiation with respect to eta A, so minus eta A will be 1. So minus here and eta A d eta A. Okay. So it will be something like this. So it will be ln x 1 upon x. So 1 upon 1 minus eta A. Now you will go inside 1 0. Differentiation of 1 will be 0 and minus eta A will be minus d eta A is equal to. Now here. So here what I'm going to do? So here I'm going to doing with respect to Cv. So here minus R ln R as it is. Differentiation of 1 upon Cv means 1 upon x minus 1 upon x square. So minus 1 upon Cv square and Cv dCv. Okay. So here I'm going to with respect to Cv. Here I'm going to do with respect to eta A. So this can be like this. Now this can be written minus 1 upon 1 minus eta A d eta A. This will be minus minus plus. So it will be R. I have just rearranged the term, so it is R dCv ln R upon Cv square. Now what I'm going to do? I'm going to divide this both the things by eta A. So here if I will divide these two terms by eta A, so d eta A upon eta A, and this 1 minus eta A will go this side, this minus also go this side, and also I'm going to divide by eta A, so that's why eta A over here. So what I have done, I have divided both this term by eta A. So that's why you can see eta A over here, and this minus side will go over here and this 1 minus eta A will go over here, and I have written this something like this R upon Cv dCv upon Cv ln R. So I have to just rearrange this term, okay, like this. Now therefore d eta A upon eta A minus 1 minus eta A upon eta A. Now you know that in place of R upon Cv can I write gamma minus 1, because you know that gamma minus 1 equal to R upon Cv. So in place of R upon Cv I have written gamma minus 1 and this will remain as it is ln R dCv upon Cv. So this is the effect of variable specific heat as standard efficiency of Otto cycle. So here what is negative sign indicates? Negative sign indicates that if you increase the value of Cv means specific heat will increase, your efficiency is going to be decreased. So that is what the negative sign is indicating over here. So if they ask you effect of variable specific heat on air standard efficiency of Otto cycle, then you have to derive this equation up to here. Now the same thing what we have to do for diesel cycle. So now for diesel cycle we have to start from here. So now we're going to start the theory for diesel cycle. So diesel cycle simple. We know that the efficiency, as standard efficiency, eta A is equal to 1 minus 1 upon r raised to gamma minus 1 bracket rho raised to gamma minus 1 upon gamma rho minus 1, where r is compression ratio and rho is cutoff ratio. Okay. So now again rearrange the term. So 1 as it is, I will take eta A on this side. So 1 minus eta A. This will come on this side. So it will become positive. So 1 upon r raised to gamma minus 1 rho raised to gamma minus 1 upon gamma rho minus 1. Now what I'm going to do? I'm going to take log both the sides. So I'm going to take log both the sides. So this will be ln 1 minus eta A. Now here you're going to see that this is r raised to gamma minus 1 upon r raised to. So can I write r raised to minus gamma minus 1? If 1 upon x, so can I write x raised to minus 1? Similarly 1 upon r raised to gamma minus 1 there. So can I write r raised to minus gamma minus 1? And if I will apply ln over here, so minus gamma minus 1 over here, and then you can write ln of r. So that's why it is over here. Same way here, this is in multiplication with this. So you know that if ln is multiplication, then it will be addition. So this term is multiplication with this rho raised to gamma minus 1. So that's why here plus sign and then ln rho raised to gamma minus 1 over here. Same way now this term is in division. So this will be, there will be a subtraction. You know that ln A upon b is equal to ln A minus ln b. So this denominator term will be in minus because that is the law of logarithm. So this is minus ln gamma minus ln rho minus 1. So it will be something like this. Now we're gonna do differentiation over here with respect to eta. So 1 ln x 1 upon x. So ln 1 minus eta, so it will be 1 upon 1 minus eta. Now eta minus eta will be minus d eta. Now some of you think why d gamma over here? Because I am going to differentiate this whole term with respect to gamma. So here it will be d gamma. So I have taken that d gamma over here. So actually this d gamma is over here, but I have taken over here. So I am going to differentiating with this term with respect to gamma. So here, if I am going to do over here, so you can see that with respect to gamma, so this will be what? So ln r as it is, differentiation of gamma will be 1, this one will be 0, minus sign will be n, so that's why it is minus ln r. So we are differentiating with respect to gamma, plus over here. So what we gonna do? ln x, so 1 upon x, so 1 upon rho raised to gamma minus 1. Now we going to do differentiation with respect to gamma. So this is a raised to x. So you know the differentiation of a raised to x will be what? A raised to x log a base e. So this is similarly rho raised to gamma ln rho base e. Okay, minus here with difference with respect to gamma. So ln x 1 upon x. So ln gamma 1 upon gamma. And now here what will happen? So now we gonna do it, this is ln rho minus 1 and we are going to differentiate with respect to gamma. So this is constant, so this will be 0 and here will be d gamma. So this will be cancelled because this is constant 0 and this d gamma I have taken over here. So that's why I have not written d gamma over here. So it will be something like this. Now I'm just going to rearrange terms. So dna d eta upon d gamma. So it will be like this. I have taken 1 minus eta on that side. Now this minus sign, what I'm going to do? I'm going to apply this minus sign over here. So multiply both the side by minus 1 minus 1. So this is minus minus plus, and if you apply minus over here, so minus minus plus, this plus will be minus, this minus will be plus because we are applying minus sign over here throughout the equation. So this minus minus plus, so this is plus, and this minus minus plus, this is minus, and this minus minus plus. Okay, now what we gonna do? Now we gonna divide this both the term by eta. So d eta a by eta a. Okay, this d gamma will go up, so it will be over here 1 minus eta as it is, and dividing by eta. So both side dividing by eta. Okay, and I will just rearrange the term. Other term will remain as it is. Now we know that Cp minus Cv is equal to R, and we know that gamma minus 1 is equal to R upon Cv. Now from gamma minus 1 equal to R upon Cv, here I am going to differentiate both the side with respect to gamma. So if the differentiation of gamma will be d gamma 1 0 R as it is 1 upon x minus 1 upon x square, so minus R upon Cv square, and differentiation of Cv will be dCv. So I have differentiate this thing with respect to what? With respect to here I have with respect to gamma, and here with respect to Cv. So here d gamma, here dCv. Okay, so now just rearrange the term. So can I write d gamma is equal to minus R upon Cv into dCv upon Cv? So I have just rearrange the term. So you know that but R upon Cv is equal to what? So R upon Cv is equal to gamma minus 1. So can I write in place of R upon CV, gamma minus 1. So minus gamma minus 1 dCV upon CV. So what I'm going to do, I'm going to just write this term again over here, but I'm putting the value of d gamma is equal to minus gamma minus 1 dCV upon CV into over here. So what will happen? So this will be as it is. So I'm just going to put this value over here. Okay. So what I'm going to do, d eta upon eta as it is. Then in place of d gamma, what I will write? Minus gamma minus 1. So that's why you can say minus gamma minus 1. 1 minus eta as it is. This term as it is. And dCV upon CV. So it will come over here. dCV upon CV. So what I have done? I have just write this term again over here by putting d gamma is equal to minus gamma minus 1 dCV upon CV into here. So what in place of d gamma, what you gonna write? Minus gamma minus 1 dCV upon CV. Just put minus gamma minus 1 dCV upon CV. So that's why this equation will be like this. Okay. So this is the final derivation for diesel cycle. So this is how you can derive the equation for Otto cycle and diesel cycle. So this is the important theory, which is effect of variable specific heat on air standard efficiency on Otto and diesel cycle. So we're gonna see effect of variable specific heat on dual cycle. Okay, so now we have already studied effect of variable specific heat on Otto cycle and diesel cycle. Same way you have to do for the dual cycle. So what I will do, I will do up to 90%. I will do it, and then 10% I will left for you. Okay, so you have to do it. So now you know that as we have already done same way as we have already done in Otto and diesel cycle, same way you have to do for dual cycle. So we will start from the here that the efficiency of the dual cycle is given by 1 minus 1 upon r raised to gamma minus 1 bracket alpha into rho raised to gamma minus 1 upon alpha minus 1 plus gamma alpha rho minus 1, where r is compression ratio, rho cut-off ratio, and alpha is pressure ratio. Okay, so now what we gonna do? First we will put it rearrange the term. So can I write 1 minus eta is equal to 1 upon r raised to gamma minus 1 bracket alpha into rho raised to gamma minus 1 upon alpha minus 1 plus gamma alpha rho minus 1. So I will just rearrange the term. Now what I am going to do, I am going to take ln both the sides. So I am going to take ln both the sides. So here ln 1 minus eta is equal to ln. What I have done, r raised to gamma minus 1. So can I write r raised to minus gamma minus 1, then alpha, then rho gamma minus 1, and this denominator as it is. Okay, so I have just put it ln on both the sides. So this is ln 1 minus eta. So now what will happen? This is ln a upon b. So it is l minus, so ln a upon b. So division rule. So ln a minus ln b. So this will be what? So this will be what? So minus r gamma minus 1 r here, and then ln r plus ln alpha plus ln rho raised to gamma minus 1 minus into minus big bracket this b alpha minus 1 plus gamma alpha rho minus 1. So this is how you can write it. Why? Because you know that this is 3 r raised to minus gamma minus 1 alpha and rho raised to minus 1. These 3 are in multiplication. So the addition of these 3. So this and this is denominator. So minus ln into this. This is what I have done. Okay, and this gamma minus 1 will come over here, and then will ln r. Okay, so it is something like that. That's we already done in last video. Now what we gonna do? We gonna do differentiation. So we gonna differentiate this term with respect to eta and this whole term with respect to gamma. So if you differentiate this term with respect to eta, it will be a ln x 1 upon x. So 1 minus eta will be minus d eta, and here will be d gamma. So I have taken d gamma over here. So this d gamma actually over here, but I have taken d gamma over here. So now differentiate this whole term with respect to gamma. So if you do is with respect to gamma, so differentiation gamma with respect to gamma 1. So this will be minus ln r plus ln alpha. So this is constant 0. Here ln rho raised to gamma minus 1. So differentiation of this with respect to gamma will be what? Ln x 1 upon x. So 1 upon rho raised to gamma minus 1. And this is a raised to x. So a raised to x log a base e. So rho raised to gamma ln rho raised base e. Now come over here. So minus ln x. So 1 upon x. So with respect to gamma 1 upon whole this term over here. So 1 upon alpha minus 1 plus gamma alpha rho minus 1. Now go inside. So with respect to gamma alpha minus 1 is constant. So this will be 0. And with respect to gamma 1. So this will 1 into alpha rho minus 1. So alpha rho minus 1 over here. Now what we gonna do? We gonna just rearrange the term. So what I'm gonna do? I'm gonna divide both this term by dividing both this term by eta. So d eta upon eta, and here also eta, both side. 1 minus eta will be on that side. Now what I'm going to do? Both side multiplying with minus 1. So this is d eta upon eta. D gamma will be over here. Okay. This both side dividing by n, and minus both side multiplying by minus. So here what will happen? So this will go inside minus minus plus, plus minus minus, minus minus plus. Okay. So now this equation is ready. But now we want to put it, we have to simplify it further. So we know that gamma minus 1 is equal to what? R upon CV, that we already know. So now differentiating this equation with respect to gamma. So this is with respect to gamma, this will be d gamma, and this equation with respect to CV. So 1 upon x minus 1 upon x square, so minus R upon CV square dCV. This will be, so therefore can I write d gamma is equal to minus R upon CV into dCV upon CV? Can I write like this? So now what do we know? D gamma. Now we know that R upon CV is equal to what? Gamma minus 1. So can I write d gamma is equal to minus gamma minus 1 dCV upon CV. Now what you have to do? You have to just put the value of d gamma is equal to minus gamma minus 1 dCV upon CV into this, and just write it down over here. That I am going to left with you. Then that will be your answer. So now in this video what we have covered, we have covered the effect of variable specific heat on Otto cycle, diesel cycle, and dual cycle. So this is very important from GTU examination point of view. So up to MSc1 in this chapter we have topic up to here. Okay, so we have covered the topic of MSc1 up to here. For this chapter remaining portion we will cover in the when we start the MSc2 syllabus. Okay, so now we will move on to the next chapter. Okay, done. I hope you will like this video. Have a nice day. Bye.